All right, guys. Today we're still dealing with exponents. If you remember the last unit, we talked about multiplying and dividing, or just multiplying. It was really weird. Some random laugh out in the hall. But we did multiplying. What was the rule when you multiply with a common base? What do you do with the exponents? Do you guys remember? You add them. So it was like this. We had x to the third times x to the fourth. What would that be? X to the what? Seventh. Do you guys remember that? And the other one that we talked about was this. X to the third to the fourth power. What is that? You multiply those and you get x to the 12th. Yes, you guys remember that now? Now, today we're going to be doing, you're still doing exponent rules, so the notes are going to be a little bit longer again, but they're not going to be as long as last time, okay? This will probably take about 20 to 25 minutes, okay? It's going to take a little bit, but because you kind of already have an understanding of what the rules are, and you have an understanding of exponents, I shouldn't have to explain how exponents work. Would you agree? So it shouldn't be crazy long, but there is a lot of stuff we need to cover. I do need to cover the dividing rules. I need to cover negative exponents, and I need to talk to you about zero. We've already talked about what is zero. What is zero always? Zero is always one. So we've kind of talked about it. So it shouldn't be anything crazy. At the end of the class or during the class today, you're going to have a quick check, okay? And then after the quick check, we're going to do the quick check before we do the practice, okay? Because the quick check is all about multiplying off what we did on the last unit, okay? So we'll do the notes. We'll do the quick check from last time, and then I will give you a little bit of practice today, and hopefully you get some extra time today to just kind of chill and relax because it's Friday, and, well, we all just want to chill. Cool? All right, but we got to get our work done. All right, here we go. Using the definition of power to power is to rewrite the numerator and denominator as a product, then simplify it. So here we go. All I did was I read the top. 9 to the fifth over 9 to the second power. Now, what does 9 to the fifth mean, guys? Yeah, so how would I write it? 9 times 9 times 9 times, I sound like an angry German. Okay? 9 is no in German. Okay? 9. Okay? And then what's 9 to the second power? 9 times 9, right? Now, forget about this problem for just a second. If I ask you to solve this, 3x squared over 3y, couldn't I just cancel those out and just say x squared over y? You guys remember that? Okay, I can cancel out numbers because if they match, I could just cancel them. Yes, 3 divided by 3. It's the same sort of thing here, okay? Can I cancel these two 9s right here? Yes, can I cancel these two 9s? Is there anything else I can cancel? No, so how many 9s are left? 3, where are they? They're together on top or bottom? Top, so I don't need to write it as a fraction. My answer is 9 to the third power. I'm done. That is literally it. Okay, now this class is smart enough, I can just flat out ask you, what did I do? I just subtracted the exponents, okay? I just subtracted the exponents. When you have a common base and you're dividing, sit up please. When you're dividing and you have a common base, kind of like it's opposite of what we did the other day. When you multiply with a common base, you add the exponents. That's what we did on Wednesday, right? Today, when you divide with a common base, you subtract. So it's just opposite. Everybody get me on this? Everybody good? So go ahead and do number B. Well, whatever. You get what I'm saying. By the way, there are no 6, 7 answers today. No 6 to the 7th powers. That's good. All right, you got 5 to the 6th over 5 to the 3rd. What do you got? What? 5 to the what? 3rd power. Simple. All right, let's do this one. Oh, by the way, if you want to go quicker, you got to participate. If I got to wait on you to talk to me, it's going to take a little bit longer. All right, here we go. Letter C. What do you got, guys? Z to the 2nd power. Pretty simple. Okay, good. What about letter D? Why are you confused? Because they're not the same bases. It's kind of a trick question. You can't do anything with that. Okay, so you can just circle that one to say cannot simplify. Or it's already simplified. Because the bases don't match, I've got a base of u and a base of x. I can't do anything with that. If they don't match, they can't cancel out. Okay? Everybody good? Clear as mud? Moving on. What relationship do you notice? So here we go. When you divide, when you divide common bases, you subtract the exponents. This is just, isn't it just like the notes from the other day? Like it looks the exact same. Okay. When you divide with a common base, you have to subtract the exponents. Okay. Now, the way that you would officially write that rule would be this right here. So if I have x to the a over x to the b, I'm going to keep that base, the x, and I'm just going to go a minus b. I keep the base, the x, and I just subtract my exponents, a and b. Basically, it doesn't really matter what the exponents are. I'm going to subtract them. That's an a. Dude, don't make fun of my a's. Don't make. Is that better? All right, thank you. Thank you for judging me. Haters. All right. Everybody good? Nod. Remember I told you guys you got to participate. We can go a little quicker. Everybody good? Cool. Let's move on. Tyson, you good? All right. You need to participate too. Moving on. All right. Here we go. Simplify the expressions below using the rules. All right. Do letter A. Go. Really quick. Talk to your neighbor if you need to. What'd you get? 6 to the 5th power. That should not have been a problem. 8 minus 5. Or 8 minus 3. I'm sorry. 8 minus 3. You just subtract the exponents. Okay. What about B? Hold on. Solve this problem like there's no negative. What would you get? 9 to the 2nd power. So what do you think I'm going to do with that negative? Or just take that negative and just put it in the answer. Because if I ask you, remember the other day I asked you what about a base and an exponent? The base is what's repeating. The 9 is being repeated. Would you agree? The 9 is being repeated. There is still that negative is not included in what's being repeated. So I'm going to basically just put it on the front of the answer. Okay. Everybody good? All right. Letter C, letter D. Go. Letter C, what can I do? It is already simplified. Okay, or cannot simplify. Why not? They have 2 different bases. Good. That's exactly right. Even though the exponent matches the bases and the bases matches the exponents, I can't do anything with it because because they don't match. Now I could simplify it and go 2 to the 3rd power is 8 and 3 to the 2nd power is 9, but I didn't ask you to do that. Okay? Yes.
Is there like an abbreviation like for like simplify? Like can I just put like C and S?
Sure.
I just don't like writing.
You could put down like, bro, I can't do this any further, so I'm just going to leave this problem just like it is, period. You can simplify it to that if you want to. Okay. Maybe not. Okay. All right, let's do letter D. All right, this one's gonna be a little confusing. Can I write this? I'm gonna put this in different colors. Fair? Yes. Watch what I do here. Okay. Watch what I do. No, you're good. You want to say hi?
Hi, video. Can you send this person down to AP office?
Right now?
If you can, or just.
Please come to 1040. Yeah, right now. Elliot Walls.
Thank you.
Okay. For a good thing. It's good. You get a reward. That's good. I like it. I just called you out on video. You're welcome. Okay. All right, here we go. Oh. You're still on video. You're still on video. I'm out in the hall. He's running. Okay. He's excited about his reward. Okay, he's good. He's good. All right. Like I look down the hall, he's gone. Okay. So here we go. Now, I did this in different colors, okay? Now, here's the problem. Sorry, I didn't want to interrupt you. Okay. What's in black? No, what are those called? Numbers that are on the front are called the what? They're coefficients, okay? These are coefficients. Yes, you do still have to simplify coefficients, okay? You still have to do them. So if I cover everything up, somebody read me that problem. 12 divided by 2. What is 12 divided by 2? 6. We're done there, okay? So that's done. Everybody with me? Now, what's the next letter? What's in green? What letter's in green? X. The X. The letter X, okay? So now just focus on the X. What is X to the 4th over X to the 1st? X to the what? 3rd. We're done. I like doing this in color so you can kind of see the gap. Am I doing this problem all at once? How did I do this? I broke it down into pieces. Do this part, do this part, do this part, and it's a whole lot easier. Yes? Okay. What is y to the fifth over y to the third? Y to the second. Now, let me show you one more way to do this. If you're struggling through this a little bit, and here's what I showed somebody yesterday. Everybody in this class might be fine, but there might be somebody watching this video that might be a little bit confused. Okay, so let me show you this just really, really fast. If I expanded 12x to the fourth, y to the fifth, wouldn't it look like this? 12x to the fourth, y to the fifth. Would you agree? And then 2x, y to the third. 2x, and then y to the third. Yes? Now watch what happens. We do 12 divided by 2, we still get 6. Agreed? I cancel out x, x, and x. How many x's do I have left? Did I? I had one. I had 2 extra x's on the bottom. Sorry. My fault. So we should have only canceled 1 out. Sorry. I wrote the problem wrong. So x and x. So I still have 3 left on top. So I have these 3 x's. How many y's can cancel? 3. 1, 2, 3. How many are still here? 2 of them. Y to the second power. So some people like to do it that way. You circle the ones that aren't canceled. Okay. Yes, sir. Because coefficient rules don't fall under exponent rules because they're not coefficients. The question was, why do I divide the coefficients and not the exponents? Because exponent rules are different, okay? If I have a fraction like 12 over 2, if I just wrote down 12 over 2, wouldn't that be 12 divided by 2? Just like a regular problem. Forget about the exponents for a minute, or the variables. If I just said 10 over 5, wouldn't that be 10 divided by 5? Yes, okay? Exponents are a different animal, so that's why we have to do it this way. That's why this whole section is called exponent rules, because the rules are a little bit different than they are with regular numbers. That's a good question. Everybody good? Did anybody else have that question? One? Okay, I saw somebody kind of start to stick their hand up. It happens. Okay, that's a great question. If you have any more questions, ask, because if you have it, somebody else might have it too. Okay, all right, here we go. Is everybody good on this page? Cool, let's move on. I'm going to pause this video for a second. What we're going to do on this one is you're going to try to simplify, or I'm sorry, you're going to do what's called error analysis. You're going to try to find the mistake in all of these problems. Okay, you're going to try to find them. This is exactly what you guys do to me every day. Coach Moy, what did I do wrong on this? This is what I do. I find your mistakes and tell you how to fix it, right? So what you're going to do is you're going to find the mistakes in all 3 problems. And I'm going to pause this video while you do it, okay? Ready, go. We're back from our commercial break. Okay. Letter A, what's wrong with it? Yeah, this should be a -8. That should be a -8. -2 to the third power. Yeah, the negative is included, but there's 3 of them. Negative, negative, negative. If it's an odd number, it's going to be negative. Okay. If it's an even number, it's going to be what? Positive. Think about it. What did 2 negatives make? So 4 negatives would be positive. 6 negatives would be positive. The odd numbers would be negative. Okay? Odds are negative. Evens are positive. If it's in parentheses. If it's in parentheses. Okay? All right, let's go to B. What do you got? Anybody find it? Go ahead, Izzy. Yeah. They subtracted, didn't they? What's 16 divided by 4? 4, not 12. They subtracted. They didn't divide. Okay? Which some of you guys will do that today when we take our quick check. It's going to happen. It's going to happen. I saw it in both my classes yesterday. Somebody's going to do it. Okay? All right, next one. Go letter by letter. Tell me if it's all right. We got x5, x2, we got x7. Is that good? Yeah. Good. Let's go to the y's. I got y7, got y1, we got y7. Is that right? This is a 1. So what do I need here? That should be an 8. Okay? And the z, listen, there's no z to combine it to, so it just becomes part of the answer. That's fine. That is 100% okay. Are we good? Is that the bottom of the page? Number 4. Here we go. Power of 0, pretty simple. We talked about this the other day, so we're going to fly through this one, okay? All right, here we go. Let's do the first one. Let's do letter C. What is 25 divided by 25? What is 25 divided by 25, guys? It is 1, right? Now, if I rewrote this problem, now this is where it's very, very important. You need to pay attention to this, okay? 0 power is always going to be 1. Now, here's the rule. You guys have been doing this since like 3rd or 4th grade division, right? Like 5 divided by 5, 3 divided by 3, 2 divided by 2, right? You know it's going to be, if the numbers match, it's 1, okay? Now, the other day we talked about this. If there is no exponent, what's the exponent? It is 1, isn't it? So if I ask you to write that in exponential form, what do you do with the common base when you divide? What do you do with the exponents? No.
Subtract them.
You subtract them. So the base stays the same. What's 1 minus 1? 0, which comes out to be 1. Yes? So it kind of works the same way. Everybody like, okay, I kind of get that. Now, did I showed you the pattern the other day, right? About why it's 1, like the dividing and multiplying and whatever. It has to stay 2 to the first, 2 to the second, 2 to the third. Okay. All right, here we go. So what would this one be? Do they match? Yes. What is it? 1. Boom. It matches. Do these match?
Yeah.
Yep, that's 4 to the 0 power. I'm going to write it a different way. That's 1, which is 1. Okay? Everybody good? All right. If there is no number, there's a 1 exponent on it. If there's no exponent, it's a 1. Okay? All right, here we go. What rule can you write? Here's your rule. X to the 0 power. It doesn't matter what it is. If it's 0 power, it's 1. Anything to the 0 power is 1. Good? All right. Let's flip over to the back. This back page is not going to take very long, okay? This back page will not take very long at all. All right, here we go. Each one. Now, there's a couple different ways that you can do this. I'm going to show you both different ways because we're going to start talking about negative exponents, okay? Now, what did I tell you that 0 power was? 1. So I could go ahead and, watch this. I can go ahead and make that a 1, which means I'm just going to leave that as 10 to the 3rd power. Everybody with me? Yes? Now, I want to explain negative exponents. Let me go ahead and do this for you, okay? Negative exponents are going to happen, okay? A lot of times, they're going to tell you write your answer with positive exponents, which means if you have a negative exponent, you need to know how to change it. Does that make sense? So watch this, please. If I just solve this problem, 10 to the 0 power over 10 to the 3rd, okay? Let's just do it like this. What do? I subtract the exponents, agreed? If I'm going to solve it. I gave you the shortcut version, by the way. I gave you the shortcut. Let's just do it the math way. What's 0 minus 3? 10 to the negative 3rd. And if there is no fraction, isn't it over 1? Would you agree? You guys remember that? Like that's any whole number. If there's no fraction, it's over 1. Like 5 is the same as 5 over 1. Okay? So a negative exponent, if I do not want a negative exponent, please listen to this is the important part. If you have a negative exponent, all you need to do is take it and just flip it to the other side of the fraction. That is all. Okay? If it's on bottom and it's a negative, I flip it to the top. If it's on top or there is no fraction, I flip it to the bottom and I make it a fraction. Okay? So like this one, it's a negative exponent, so I can't have it, so I'm going to flip it to the other side and I'm going to change it to 10 to the 3rd power. And if there's nothing on top, I'm just going to put a 1, which is exactly what we got anyway. Okay? Negative exponents, you just have to flip. What do you do with negative exponents, guys? Flip them. You just flip them. Okay? Go ahead and do letter B, letter C. Letter B and C are the exact same. So go ahead and do B and go ahead and do D, please. Go ahead. This should not take you more than like 5 seconds. We've already done A. B should be easy. D should be easy. What'd you get for B? 1 over 10 to the 5th power. What is this one? 1 over x to the 4th power. Okay, simple. By the way, your little math trick for tens, does anybody know what 10 to the 5th power is? How many, hold on, what's the exponent? It's 5. So it's basically a 1 with 5 zeros. The exponent tells you how many zeros there are. That's all it is. So I know right away that this is what, 100,000. 5 zeros. 1. Oh, no, sorry. There's my answer. How many zeros? 10 to the 5th power has 5 zeros. So 10 to the 7th power would have 7 zeros. 10 to the 11th power would have 11 zeros, and so on. Okay, so that's how 10 to the power works. You don't really need to know that for this lesson, but hey, it's a little bit more knowledge. Okay, something else you learned. Okay, 10 to whatever. Think about it. What's 10 to the 2nd power? Which means 10 times 10. What is that? How many zeros are in 100? It works. 10 to the first power is just 10, 1, 0. Okay, that's the way it always works. All right, here we go. Let's go to, I don't know what that means. All right, cool, let's go to this. What did I just tell you to do with the negative exponent? Rewrite the expression to have positive exponents only. So what did I tell you you had to do? Flip them. So what would A be?
1 over 8.
1 over 8 to the fourth power. Done. You just flip it over and you're done. Literally, that's how easy that is. Yes? Cool. What about B? 1 over 5 to the sixth power. Go ahead and finish up C and D. By the way, it's okay to flip more than one thing. Looking at letter D. Okay, I'm not going to pause the video this time. I'm just going to let you work. All right. C is 1 over what? 7 to the fifth power. And then D is what? 1 over 4 to the third, 3 to the second. Okay, I would probably put those in parentheses just because they're next to each other, which wouldn't be wrong. So I would probably do it like this. Everybody good? Just because the numbers are all squeezed together, so you see the difference. All right, thumbs up. Moving on. Okay, we're good. Let's move on. All right. So same thing here. So what is letter E? What? 3 to the second power. Done. We just flipped it over. And basically, yeah. Yesterday, somebody was like, well, I thought you had to put it over 1. No. If it's over 1, nobody ever says they have $5 over $1 in their pocket. Okay, if it's over 1, it's just a whole number. They have $5. Even though technically as a fraction, it's 5 over 1. Yes? Okay, so once you flip it, you don't have to keep it as a fraction unless there's something else there. Okay. All right. What about F? 4 to the what? 4 to the second power. What about G? X to the positive third. What about H? X to the fourth. Y to the fifth. Good. I'm not going to, that one I don't necessarily need to put in parentheses because it's not numbers, it's just letters. Wake up, we're almost done. I know it's long. Okay. Softball was, we pushed those girls early this one. It's tiring, huh? Yeah. It's good practice. All right, here we go. Try these on. Is this the last part? Okay, I'm going to pause this. I'm going to let you guys work for a minute. We are going to come back and talk about these, but I want you to solve as many as you can with your neighbor and see if you guys can get all the way through them. If you can't, just mark it and I will come back and we will work through them. Fair? All right, go ahead and pause it and go. I'm going to unpause the video really, really quick because somebody had a pretty good question. When you have a negative, you only flip what is negative. Let me show you this really, really quick, okay? So I'm going to give you a small example. If I have x to the second, y to the negative third over z to the negative eighth, okay? Is the x to the second okay?
Yeah.
Yes, it is. I'm going to leave it alone. X to the second. Is the y to the negative third okay? Can I have a negative exponent? No. So what did I tell you to do? I told you to flip it. So I'm just going to take it from the top to the what? Bottom. So now I put y to the third on bottom. Now we're okay. Now let's talk about the z to the negative eighth. Right now it's on what? The bottom. It's got a negative. So where do I put it? Where does it go? The top, z to the eighth. I'm done. Now I've written everything. You want to wave?
Hey.
I have written everything with a positive. You guys with me? But I went letter by letter, number by number, and whatever was negative, I flipped. I don't flip the entire thing. I just flip the part that has the negative. Everybody with me?
Mm-hmm.
Go ahead and finish. We're back. Okay. What'd you get for A? F to the fifth power. Good. What'd you get for B? Wait, no, I'm waiting to hear an answer. I'm waiting to hear the right answers.
2-1 over G.
2-1. 21? No, not 2G to the second.
2 over 1 G to the second.
You're probably 2 over 1G to the second. Do I need to say 1G?
No.
No. So we know that 10 divided by 5 is 2. Yes, everybody with me on this? If you're confused, can I just expand them out? Can I just show it to you that way? G4, G6. Okay, how many G's can I cancel? 1, 2, 3, 4. Yes? Where are my remaining G's? I said that yesterday and somebody raised their hand. I'm right here, coach. Like you are not a G. Okay. All right, so I got 2 over G to the second power. Okay. Now, a couple of different ways you can look at this. You can go 4 minus 6, which is negative 2, and then you have to flip it back to the bottom. Yes? Or you could just say 4 and 6. If I subtract the numbers, how many are left? 2, right? And where are most of them at? If I have 4 on top and 6 on bottom, where my remainder is going to be? Bottom. So either way you look at it, it's the same problem. Does that make sense? Everybody with me on this? I see a lot of nodding. Is everybody okay with that? All right, cool. Let's go to C. Go. What's 30 divided by 15? 2. What? H8, H2, H6. Just subtract them. We're good. A lot of people forgot the H for some reason last time. Anybody forget the H? Okay. Like I said, after 20 years of doing this, I'm kind of used to the mistakes, so it doesn't surprise me. All right. 35 divided by 7. 5. You notice how I didn't say anything about the letters yet? I did the numbers first. Just take care of the numbers, okay? Those are done. X7, X2, X5, Y3, Y3. Nope, don't say Y. Do not, nope. Well, it's 1. Do not say Y. Do not ever say Y. Hold on. If you have Y3 over Y3, think about it. What's 3 divided by 3? 1, which means basically everything cancels. If you say Y, that means everybody has done that, okay? So don't feel bad. It's a good point because I was actually going to say it too. Don't say Y because what is Y with the exponent if there is no exponent? What is the exponent? You assume that there's 1 left. Don't assume that there's 1 left. If it is Y3 over Y3, they all cancel out, and this is actually my answer. I don't need to put the 1 because there's something else there. The 1 is if nothing else is there. Does that make sense? Okay, don't put 0, but don't ever put 0, by the way. Okay? All right, everybody good? What is E? What is E? 1. Okay? What is up? Now, this is kind of what you're about to quiz on, so let's talk about it. Let's do the first one. Anybody get it? What are my numbers on the front? What is 4 times 8? 32. Please don't overthink that. Hold on. What? Are they exponents? This is the same question he had. Why do we treat the numbers on the front different? Because they're not exponents. Okay, these are exponent rules. The numbers on the front are not exponents. Those are coefficients. So we just do whatever it tells you to do. Now we go B2 and B9, which is what? B11, because when you multiply with a common base, you add the exponents together. That's what we talked about yesterday. I see a lot of nodding. People are like, okay, I'm starting. This. Would you agree this is one of those things just going to take some practice? Repetition. Okay. All right. What about G? Now, 10 to the 5th power, I can just expand it. Yes. Now, on your quiz today, I actually want you to solve what 10 to the 5th power is. Okay. A lot of people yesterday made the same mistake. What they tried to do was say, well, 10 to the 5th power is just 10 to the 5th power. No. Solve the problem. Your calculator will do it for you, by the way. 10 times 10 times 10. Or you can just put 10 to the 5th power. Okay, so one thing people did yesterday. Can I show you the mistake? They did this. They went e to the 5th, and they went f to the 15th, which is correct. When you have a power of a power, you multiply, yes? A power of a power, you multiply. But what they did not do was this, and they left the 10 there. Don't do that. Because the exponent goes to everything inside. Everything. Everything gets the exponent. And if you're confused by that, expand it. Write it 5 times. Who cares? If you get it right and it gives you a higher grade, why not just spend the time and write it out? Yes? Write it, because if I do that, we'll see how long it takes. 10 e f to the 5th, or to the 3rd, right? And we're going to do this 5 times. 10 e f to the 3rd. 10 e f to the 3rd. And 2 more. 10 e f to the 3rd. 10 e f to the 3rd. That probably took me 20 seconds. Yes? Now you can see 10, 10, 10, 10, 10, which is 100,000. It's 100,000, 5 zeros. Okay? So that would be 100,000. How many E's? 1, 1, 1, 1, 1. How many E's? 5 of them. 3, 3, 3, 3, 3. What's 3 times 5? F to the 15th power. If you need to write it out, write it out. You guys with me on this? This is actually what you're about to take your little quick check on. Does everybody understand what I'm talking about here? A lot of people are forgetting to do that. On your quiz today, you're going to see 2 to the 3rd power. Don't put 6. Somebody's going to put 6. I've had people do it in both my classes. Didn't I say that the other day? Somebody's going to go 2 to the 3rd power and say 6. It's on the quiz day, and somebody's going to do it. Okay, and I'm going to laugh. I'm going to tell you, hey, you did it. I told you were going to do it. All right, everybody good? So in recap, let's go back to yesterday. When you multiply with a common base, you add. What's the power of a power? Let's go over here. We're gonna slide over here to this side because I've already got it written down. Here, right there. All right. So I've got when I multiply with a common base, what do I do with the exponents? I add them together. Power of a power, what did I do? I multiplied them. When I have a fraction, what do? I subtracted them. Negative exponent, what did I do? I flipped it, or I just left the most of them on bottom. Okay, you guys with me on this? Good job today. Open up to Canvas, and we will go from there.